Hello, in this video tutorial, I want to go over how to convert a quadratic equation that's initially in standard form into vertex form. After we do that, I want to answer a few application problems. So let's begin with example 1, rewrite the equation in vertex form. In order to convert this quadratic equation that's written in standard form to vertex form, I will need to complete the square. Recall that to complete the square, we emphasize the first two terms, the x squared term and the x term. I notice that the coefficient of x squared is not 1, so I'll need to factor out that coefficient. I'll need to factor out the negative 2. In doing so, I'm going to get negative 2, and I'm going to multiply it by this parentheses. And to find out what goes inside these parentheses, I divide each of these terms by whatever it is that I factored. So negative 2x squared divided by negative 2 gives us a positive x squared. And positive 12x divided by negative 2 gives us a negative 6x. I still have the negative 4 right here at the end. Now that I've factored out the coefficient of x squared, I can zoom in inside of the parentheses and begin to complete the square. To find the value that will make this into a perfect square trinomial, I need to get the b term divided by 2 and then square it. In this example, the b term is going to be negative 6 since that's the coefficient of x. So getting negative 6, dividing it by 2 and then squaring it is going to leave me with, negative 6 divided by 2 is negative 3. And if we square that, we get a 9. So I'm going to need to add a value of 9 to make the perfect square trinomial. This means that I have negative 2 multiplied by x squared minus 6x, and then we're going to add 9 to get the perfect square trinomial, and we have minus 4. To maintain the equality, we need to cancel out whatever it is that we included right here inside of the parentheses. But because we have a factor of negative 2, in order to get the correct quantity, I'm going to get the opposite term. The opposite of negative 2 is going to be positive 2. And I will multiply it by the quantity that I used to complete the square here. That's going to be a positive 9. And now I can begin to simplify this equation. I have y equal to negative 2. I can exchange the perfect square trinomial for a binomial squared by grabbing x and adding half of the coefficient of x. So half of negative 6 is going to be negative 3. Then I have negative 4, and 2 multiplied by 9 is positive 18. And simplifying this further, I'm going to get y equal to negative 2, x minus 3 quantity squared, and negative 4 plus 18 will leave me with a positive 14. And this is my vertex form. Now that I have the vertex form, I want to add some context to it and answer a few application problems. So here we have a submarine is submerged and in distress. It shoots a flare into the air to signal for help. The height of the flare can be modeled by the equation y equals negative 2 multiplied by x minus 3 quantity squared plus 14. Here's what's happening. We have some water, and there's a submarine that is submerged and distressed. So it went underwater and it got stuck. And now it's going to shoot up a flare because it's trying to signal for help. And then the flare goes down. I also want to make a note that it should make sense that the parabola is facing down since we have a negative here. So the concavity is concave down. Now let's answer the first question, which says, how long is the flare getting higher? How long? So notice that that's trying to measure the time. So here, if I add some labels, we can consider the water to be the x-axis, and that's measuring the time. And then here, if we put a y-axis here, I'll do it in yellow. if we create a y-axis, the y-axis is measuring the height. I'm going to move the equation right here on the left to the left, and looking at the diagram again, we can see that the flare, if we're looking at part A, the flare is getting higher all the way up until we reach the peak, or until we reach the vertex of the parabola. And I can get the vertex just by looking at this equation, since we have the form a x minus h quantity squared plus k. And recall that when we have vertex form, your vertex are the coordinates h and k. For this specific example, that's going to be 3 and 14. So my vertex, I'll label it as 314. The 3 is going to represent time. The 14 is going to represent the height. So how long is the flare getting higher? Well, that's going to be 3 minutes. The problem itself didn't specify the units for time, so I chose minutes. It also doesn't specify the units for height. So if it was asking how high did the flare get, you would just say 14 units. Okay, moving on to part B, how deep is the submarine? In order to answer this question, we're going to need to solve for the y-intercept, since that's where the ship got stuck, and that's where the whole parabola begins to get mapped out. Recall that for the y-intercept, that's where x is equal to 0. So here, we're going to grab this equation, and we're going to replace x for a 0. So we get -2 multiplied by 0 minus 3, quantity squared, plus 14. And now we have to simplify the right-hand side. Following the order of operations, I'm going to simplify what's inside of the parentheses first. So 0 minus 3 is -3. Next, I am going to do the exponent. -3 times itself, that's going to give me +9. Now I'm going to multiply. -2 times 9 is -18. And adding by the 14 is going to result in 4. So the submarine is 4 units deep. And this is actually -4. Now for part C, it says, what does each of the x-intercepts represent? Referencing the sketch that I made, we can see that the x-intercepts, well, the first one is when the flare shoots out of the water, and the second one occurs when the flare begins to die out and falls back on the water. And that would be the application problems.